Welcome to a brief review of slopes. A couple things here in terms of what slope is. Slope is a measure of the steepness of a line. So the different lines that I can draw, as I draw this line is a positive sloping line. It is going uphill. No matter where I put it here, it is a positive sloping line. As soon as it becomes horizontal, now its slope is 0. And when I drop below horizontal, now it has a negative slope. If I go all the way to a vertical line, that slope becomes so steep that it is unmeasurable, and we say that that one is undefined. So I'm going to put a couple different examples up here to look at. We've got our vertical line. This one has a slope that is undefined. It is too steep to measure. We've got our horizontal line. This one has a slope equal to 0. It has absolutely no steepness at all. And then we've got a positive sloping line. It's going uphill. And a negative sloping line. It's going downhill. So this one would have a negative slope, and the other one would have a positive slope. To actually calculate the value of that steepness, we're going to make a ratio or a fraction of the rise to the run. So we'll take a line and we'll measure from one location on the line to another. How much do we rise up? That's the rise right here. And then how much do we run over? And so there's our run. It's the change in y, that's our rise, divided by the change in x. And sometimes you'll see it look like this. If I take the two y coordinates of the points and subtract them, that is my rise. And then if I take the two x coordinates of the point and subtract them, that finds for me my run. And so that would be how I would find that slope. So if I want to look at a graph here, if I want to find slope, I essentially need to find two locations on that line that I can measure. I do not want to pick points like this one right here, because even though I know the height of that point, I cannot be specific about the x value of that point. So that would be a bad point to choose when trying to find the slope of that line. Rather, we want to pick points like this one, where we can state exactly both the x value and the y value of that point. So I've gone through already and marked a number of different locations on the line. And from any one of those points to another, I'm simply going to count. How much do I rise up? In this case, I'm going to go up 3. And how much do I run over? In this case, a positive 1. And so the slope of line A would be a positive 3 over positive 1, or I can simplify that just down to 3. Notice if you've correctly identified the slope, you should be able to continue that pattern up 3 over 1. I can go down 3 and backwards 1. And if I made that slope negative 3 over negative 1, because they're both negative, that would simplify still to a positive 3 over 1, or 3 for that slope. So it doesn't matter which points you pick on that line. If I picked points that were further apart, like I'd picked these 2 points and calculated the slope, then my run would be 2 and my rise would be 6. But notice that it still is going to simplify down when I do 6 over 2 to a 3 over 1 slope. All right, a little bit faster here, line B. If I'm going from this point here, I'm going to run positive 2, but then I'm going to rise downward, so I'm falling negative 4. So the slope for line B, rise over run, is negative 4 over positive 2, or in other words, negative 2 over 1. Or I could state that that slope is negative 2. Line C, when I pick 2 points here, to get from this point to that point, my rise is negative 3, but my run, I'm not going left and right at all. So this one has no run. It has rise, but it has no run. And when I have no run, I'm trying to divide by 0. I'm saying how many zeros does it take to get to negative 3? And that's impossible. And so anytime you see a vertical line or a slope with no run, you know that you're going to have an undefined slope. Horizontal line, on the other hand, when I try to measure its slope, I've got run. Right here I have a run of 1, 2, 3, 4, 5. I've got a run of 5, but I have no rise. I don't go up or down at all. And so when I calculate this one, I get 0 over 5. This one has no rise. And so this division says how many 5s does it take to get 0? And that's 0. And so the slope of this line is 0. So just remember, or calculate each time, but you can just remember that a vertical line, straight up and down, a vertical line has a slope that is undefined, whereas a horizontal line, and that's a line that goes like this, like the horizon, a horizontal line has a slope of 0. If I don't have a graph, but instead I'm just looking at 2 points, I can still find my slope. I need to find the rise, which is what I get from finding how the y values are changing. And I put that over the run, which is what I get by finding how my x values are changing. Now, it doesn't matter which order you choose to do your subtracting in. You just need to be consistent. So if I'm going to go 7 and subtract 5 to find my rise, I have to make sure that I start at the exact same point, which means over here when I use my x's. And I'm going to go 4 subtract -2. So 7 subtract 5 gets me a positive 2 on top. And 4 subtract -2, the double negative makes this a plus, gets me a positive 6 on bottom. And so my slope is going to simplify down to 1/3. Now remember I said it didn't matter which order we went in as long as we are consistent. So if I had started my y's and instead went 5 minus 7 on top, that would have been fine as long as when I went to the bottom, I went from that same point over here for the x's and went -2 minus 4. Notice 5 minus 7 gets me -2. -2 minus 4 gets me -6. And a negative divided by a negative is a positive. So I get the same slope again, either way, regardless which order I subtracted in. Let's do this again. Next set of points, 7 minus 7 on top, 3 minus -1 on bottom. So on the top I get 0, on the bottom I get 4. And how many 4s does it take to get to 0? That is 0. This one, when the y values are the same, if I think about graphing this, 3, 7 and -1, 7, if the y values are the same, I have a horizontal line. And a horizontal line has a slope of 0. If you haven't yet tried this yourself, pause the video and try these next 2 problems on your own. Once you've got them, hit play and see what they are. So finding the slope from these 2 points here, I'm going to do the same thing. From y to y, notice I'm drawing the arrows in to help make sure that I'm being consistent here. So from 7, subtract -3 on top. And then on the bottom, I'm going to take the y values now, starting at the same point. And I'm going to go 5, subtract 5. So on the top, 7 subtract -3. Again, double negative makes plus a positive. On the top I get 10, on the bottom I get 0. And this says how many zeros does it take to get to 10? You can't do that. So this one is undefined. Again, if you think about graphing this, I'm going to go 5, 7 and 5, -3. This one's going to get me a vertical line. And because I have a vertical line, I know that that slope's going to be undefined. Last problem, same idea. Y minus y goes on top. So 6 minus -2, trying to figure out how the y's are changing. X minus x on bottom. So 1 minus 7 down here. 6 minus -2 gets me 8. 1 minus 7 gets me -6. Dividing out, simplifying down, gets me 4 over -3. So the slope of that line has a rise of 4 for a run of -3. If on any of these you're uncertain, just take yourself a graph, plot your points, 1, 6, 7, -2, and think it out. Right here, I'm going down 8. Here I'm going to the right 6. My slope, -8 over +6. simplifies down to -4/3. It's the same thing I got by calculating it with the points. Now, special lines, we did go over this, but the more you start to recognize them, the easier it will be for you. If you start to recognize that every time you have a horizontal line, you're going to have no rise, but you will be running left and right. And so you're going to end up with a line that has a steepness of 0. As the line tips upward, that slope becomes positive. Or if it tips downward, that slope becomes negative. It gets further from 0 the steeper it gets until it gets too large, either positive or negative, to measure. And then we end up with our vertical lines. Vertical lines, as poorly drawn as that was, vertical lines have no run. And so they have a rise, but they have no run. And those are the ones that are undefined. They are too steep to measure. Finally, slope as a rate of change. If I actually graph out an application problem, I would have my time in this problem on the x-axis and my miles on the y-axis. And I would be looking at, as time goes on, from 9 a.m. up to 2:30, somewhere over here. And I'm looking at, here at 9 a.m., I have 850 miles yet to drive. And then at 2:30, I'm down to 480 miles left to go, and I want to know my speed. Now, speed is typically thought of in terms of miles per hour. And notice that when I think about the slope of this line, my rise is a change in miles, so change in miles, and my run in this particular application is a change in hours. And so the slope of this line is the rate at which I'm driving. Slope is, when we talk about applications, a rate of change. So I would want to look at this problem and I would want to say, if this is where I start and this is where I end, how did each of those different values change? So it is specific in this case. I'm starting at 850 and I'm going down to 480. So I can go 850 minus 480. And that's going to get me a total of 370 miles that have been traveled. And I'm going to put that over, making sure I start at the same place, 9 a.m. minus 2:30 p.m. Now this is going to be a little bit tricky when we think about this, because I want to think about change in time here. So when I think 2:30, let's think of this as 12 o'clock plus 2 hours later. Let's go 14.5 hours. So this is 9 hours and this is 14.5 hours. And so when I subtract that, I'm going to get a negative 0.5, let's see, 5.5 hours. And so if I divide this out now, and I'm going to pause this for a moment so I can pull out my calculator. So when I divide that out, I'm getting approximately negative 67.3 miles for every 1 hour. And so I'd say that I'm going negative 67.3 miles per hour. Now, why is this negative? You can see on the graph it's going downhill, but the reason why it's negative is because my distance is decreasing as time goes on. I could look at this, sometimes it's hard to think about this, especially with the time on the clock this way. So I might think of it instead this way and go from 9 till 2:30, how much time has gone by? That's 5.5 hours have gone by. And so I would say that that's a positive 5.5 hours. But the distance that has gone by, it's actually gone down 370 miles. The distance that I have to travel has decreased by 370 miles. And so when I divide this, I'm still going to get a negative 67.3 miles for every 1 hour. And that makes sense in the context because my miles are decreasing instead of increasing. So hopefully you feel like you've got a better handle on slope. If you need more help, again, as always, just come in and ask some questions.